Yay! Today we're looking at 7-4 solving logarithmic equations. Again, just like yesterday's assignment, we're going to scratch out inequalities. We're not going to worry about solving logarithmic inequalities. Right? So kind of taking a peek at things, some of these should be actually really easy today. As far as things go, you'll notice our notes are quite short. But we're just looking at examples of solving logarithmic equations, so your understanding of powers and how they play out into exponential form is going to be super important today. Okay? If you remember from yesterday, logs can be written in exponential form. We could do 9 to the 3 halves equals x. Oh my gosh, the problem's like done for us. All we have to do is figure out the square root of 9, which is 3. 3 to the third power is 27. And we have just successfully solved that logarithmic equation by using our understanding of how logs can be written as exponents. Okay? 9 to the 3 halves is 27. Right? Similar thinking on part B. Right? We know my base is 16, my power is 5 halves. That's going to be x. So I'm thinking the square root of 16 is 4. 4 to the 5th is 1024. All right. Obviously, this isn't as easy as everything's going to be today. But again, kind of relating things back to that calculator, no calculator quiz. These are some situations where I could put on a no calculator quiz and expect to do it with the understanding of logs versus exponents and how to calculate that in your head mentally. All right? Kind of looking at this last part, or this second part rather, not the last part. But if we're solving logs and there's 2 logs, if the bases are the same, really similar to how we solve exponential equations. If our bases are the same, we can equate our powers. If our log bases are the same and they're on separate sides of our equation, we can equate what we're logging. All right? If they're not, then we have a little problem, a little situation here. All right? So, looking here, we have 2 log bases that are the same. So, in this instance, I can equate what I am logging. All right? In this instance, subtract the 2x from both sides. You wind up with x equals 4. Pretty straightforward. The one thing we do want to do and make sure is continue to check our answers. All right? So when I plug in 4, 2 times 4 is 8, 8 plus 4 is 12, 3 times 4 is 12. So this one does work. Log base 5 of 12 does equal log base 5 of 12. Right? The next one, check again. Log bases are the same. We can equate what we're logging. Some of you are quaking in your shoes right now, and you're like, oh no, Wagner, I don't know about this. Oh, we've solved quadratic equations, you guys, right? We want to make sure equation equals 0. This chapter, when we give you these questions, they're not going to be complicated. They're not, assessing your understanding or ability to factor. So we're going to make sure these problems are quite easy. If we have x minus 3 and x plus 1, that will get our expression x squared minus 3x minus 4, which means I have answers of 4 and negative 1. Again, super important, since we're dealing with powers and logs, we need to check our answers. So when I plug in a 4, 4 squared is 16, 16 minus 4 is 12. That works. 3 times 4 is 12. That works. Perfect. When I plug in a negative 1 now, negative 1 squared is 1. 1 minus 3, or 1 minus 4 is negative 3. 3 and negative 1 is negative 3. All right? Hopefully at this point you are seeing a problem. Okay? Negative 1 doesn't work. And the reason is log base 2 of negative 3, does that equal anything? Well, 2 to what power is going to give me a negative 3? The answer is nothing. We can't log negative numbers, and we can't log 0. No number exists that I can raise 2 to a power and get a negative number. Okay? So again, super important, this idea. We cannot log negatives and we can't log 0. We can log 1, because remember, log base 2 of 2 is 1. 2 to the first is 2. We can log 1. We can't log 0. And we can't log negative numbers. So really important to keep that in mind today as you're checking your answers. Some will work and some will not. All right. As we continue on to example C here, notice, oh man, my teacher's a jerk. He just said that if the bases were the same, we can set them equal to each other. Now he throws this problem in here, and our bases aren't the same. Well, good news, at this point, we cannot solve. We have different bases, all right? You will learn eventually, but this is not a concept we're going to cover in Algebra 2. So right now, if our bases are different, you do not need to solve, okay? This would almost be like the situation exponentially, where you have like 4 to the x plus 2 and 64, okay? Bases are different, but we're able to get our bases to be the same, like 4 to the third. There's no way to relate 3 and 5 in terms of powers. So at this stage, our understanding will not work. But if our bases were, 3 and 9, maybe we could solve that. If we were doing IQs, that might be an IQ type question. But at this stage in the game, 3 and 5 have no relation in terms of base, so we cannot solve it at this point. The last question we're going to look at here is dealing with the number e again. All right, we're going to try and isolate that value, so we're going to divide both sides by 4. Wind up with e to the 2x equals 30. What we can do is switch this back to logarithmic form to solve, because we want to get that x by itself. I can't like divide by 2 or divide by e. That's not how we do it. We undo exponents with logs. So I'm going to switch it into log form, okay? We do not, just so you know, write log base e. What we write is natural logarithm, ln of 30 equals 2x. Base, natural log, the base is e. Our answer is what we're logging. Our power is our answer. Now, I'm able to divide both sides by 2 to get x. And in this case, in this situation, we want to make sure we round using our calculators. So what I would do is I would type in the natural log of 30 divided by 2. Again, the natural log key is on the left-hand side of your calculator. Just hit natural log 30, enter, divided by 2, enter, and you're going to get 1.701. All right. Notice on today's assignment, there's only 2 problems out of the text, and then the rest are on the worksheet. It's because our worksheet is better than the textbook, in my opinion, and Ms. Brostrom's opinion. So we gave you a few more problems on the worksheet to do. If you do have any questions, feel free to reach out via the Meet or discussion board. I'm here to help. Remember those strategies and remember to check your answers as you go through questions today. If you have any, let me know. Otherwise, best of luck.